Hi there, welcome back to Green School. We'll be doing a partial walkthrough of Cambridge International AS and A-Level Computer Science for Paper 3 Advanced Theory. We will be doing the 9618/32 variant for the October/November 2025 series. And now, let's get started. The composite data type car is defined in pseudocode as type car with all the variables here and an end type. Write the pseudocode statement to set up a variable for one record of the composite data type car. So for this question, we just have to create a new variable based on this data type. So we can just write declare my car colon car. Write the pseudocode statements to assign the following values to the variable set up in part AI. Blue to color 31/10/2025 to into stock. So for this question, we just have to assign a new variables, these two new variables into this new variable that we declare here. So we can just write my car dot color left arrow blue, and then my car dot into stock left arrow 21/10/2025. The data type for body style is changed to an enumerated type body. Write the pseudocode statement for the type declaration of body to hold the names of the available choices. So we have convertible, hatchback, saloon, SUV. So what this question wants is, if you look at the definition here, what we need to do here is that we have to declare body style into another data type called body here. So we have to create a new type first. So we can just write type body is equal to bracket, convertible, hatchback, saloon, SUV, and then close bracket. And next, write the new pseudocode statement required to update the declaration of body style in the definition of car. So we have to update this declaration here. Declare body style colon string here into this new body type here. So we can write declare body style colon body here. Numbers are stored in a computer system using binary floating point representation with 10 bits for the mantissa, 6 bits for the exponent, 2's complement form for both the mantissa and exponent. Calculate the denary value of the given normalized binary floating point number. Show your working. This is the typical question to convert binary floating point into denary value. So the first step that I will do here, I will just write down 1, 2, 4, 8, 16, 32 here to calculate the exponent here. So the exponent is going to be e is equal to 1 plus 2 plus 8 is equal to 11. And next, I will multiply this mantissa with this exponent. So I will write 0.111100101 times 10 to the power of 11. And then I will get 11110010100. Then I can just convert this binary into denary. So it's equal to 4 plus 16 plus 128 plus 256 plus 512 plus 1024 is equal to 1940. Finally, I can just write denary value is equal to 1940 here. And also, if you are taking my fast track program, you can see that for each question, I will list down the chapter and their respective topic name. You may go through the topic again in my program if you find that you're not 100% sure on how to come up with the solution at this point of time. Calculate the normalized binary floating point representation of 26.6875 in this system. Show your working. For this type of question, I will normally draw a table first. So I will draw 16, 8, 4, 2, 1, 0.5, 0.25, 0.125, 0.0625 based on this value here. So how do we get to 26? We will first use 16 and then plus 8 is equal to 24. And then I will skip 4 and then add 2 here is equal to 26 now. And how do we get to 0.6875? It will be 0.5 plus 0.125 plus 0.0625. And I will just write 26.6875 is equal to 11010.1011. So this number here, I derive from this table here. So the one we take, I will just put 1. The one without take, I will just put 0 here. And then I will just add 0 at the front here since this is a positive number here. So 0.11010.1011. And next, we have to convert this into mantissa form, meaning that I have to move these decimal places all the way to the front, which is 0.1 here. So how many places here? So 1, 2, 3, 4, 5. So it's equal to 0.11010111 times 10 to the power of 5 here. And then I can just copy all this value into the top here. So 0, 1, 1, 0, and then 1, 0, and then 1, and then 0, and then 1, and then 1 here. And for this exponent here, this is the value 5 here. So it will be 1 plus 4 here. So 1 here and then 1 here, and the rest here we can just put 0 here. For binary floating point number question, it might look a bit complicated at first, but once you follow the techniques I show in both A and B, you will find that it's actually quite doable. HTTP and IMAP are examples of protocols used in the application layer of the TCP/IP protocol suite. State the purpose of the HTTP and IMAP protocols. The keyword for this question is purpose. And for HTTP, we can remember that HTTP is used to serve our web pages. So we can just write send and receive web pages. And for IMAP, we can write allows users to access or read their emails from any device without removing the message from the mail server. So we must remember that for mail, we have IMAP and also POP3. The difference between IMAP and POP3 is that POP3 will delete the mail from the mail server, whereas IMAP here, it doesn't delete the email from the mail server. For B, describe how files are shared using the BitTorrent protocol. So this is a 4 marks question. We can just write 4 main points to get 4 full marks for this question. We can start with a small file called torrent is initially created by a peer. And next, the torrent file contains metadata about the file to be shared. And then we can write the whole file must initially be located on at least one peer. And finally, we can write each peer downloads parts of the file from other peers until the entire file has been downloaded. So we can just write these 4 main points to score 4 full marks here. Before we go to question 4, let's do a recap on the BitTorrent protocol. We'll start with the tracker at the middle. As mentioned in the previous slide, we have the original peer uploading file. Basically, it's the first guy who owns and uploads the file, and then new peer requesting download, and then the peer can act as seed once it finished downloading the file, meaning now it can share the file to others as well. Then we also have peer acting as leash, whereby it downloads more than it uploads. Of course, in real life scenario, we will have more peers like this here. So just remember this diagram and you should be able to answer BitTorrent question with ease. Identify one benefit of circuit switching and one benefit of packet switching. When it comes to circuit versus packet switching, you can visualize the picture I show on the right here. The first one is the police using the whole road and no one else can use the road. This is circuit switching. And the second one is packet switching, whereby different cars can share the same road. So for benefit of circuit switching, we can write the dedicated path ensures data is less likely to be lost. And for the benefit of packet switching, we can write bandwidth can be shared by multiple users. Identify 2 differences between circuit switching and packet switching. We can use similar definition based on the benefit of both. So we can write circuit switching uses the whole bandwidth of the transmission path, but packet switching shares it with other users. And then the second difference we can write, in circuit switching, data arrives in the correct order, but in packet switching, packets may arrive out of order and reassemble into the original message at the destination. The reason is for packet switching, data is broken into smaller units called packets. Each packet can take different route through the network. Therefore, packets often arrive out of order at different times. The packets must be reassembled in the correct order at the destination. Describe how interrupt handling is used in low-level scheduling. We can write the low-level scheduler manages the handling of interrupts based on priority. And next, it uses an interrupt service routine ISR to map the interrupt to the specific handling routine. Since this is a 2 marks question, these 2 sentences are sufficient to score full marks for this question. In process management, a process can be in one of 3 process states: running, ready, or block. Complete the table to identify one reason why a process could be in each of the 3 states. This question is from process states topic from chapter 16, and make sure you remember the diagram I draw for you on the right here. When the process state is in running state, the reason is CPU time has been allocated and the process is being executed. It just means that the process is able to run now since we have allocated resources to the process. when it's at the ready state, the process is waiting in the ready queue for a slice of CPU time. If you look at the diagram here, the next state after ready state will be running state. When the process is at the block state, the process is waiting for an I/O operation, which is an I/O operation. For example, a program will pause and wait for user to type something, and if no input is given, the process will remain blocked here. The diagram shows a logic circuit. Complete the truth table for the given logic circuit. Show your working. This question is very kind to you and have labeled all the intermediate state for you on the right here. So you just have to fill in accordingly. Let's start with P here. So for P, it's going to be a NOT gate here. And the input is going to be B here. So this is the input for the P here. And it's a NOT gate here. So when B is going to be 0 here, so P is going to be 1 here. And then we repeat the same process for all the remaining rows here. So these are the values for P here. And now let's look at Q here. So for Q, the input is going to be A and P here. And then this is going to be a XOR gate here. So for XOR gate, when either input is 1, then the output is going to be 1. So for the first row, 0, 1, this is going to be 1 here. And then we repeat the same process for all the remaining rows here, resulting in these values here. And now let's look at R here. So for R, it's also a XOR gate here. And now the input is going to be B and C here. As usual, either input is 1 and the output is going to be 1. So 0, 0, so the output is going to be 0 here. And then we repeat the same process for all the other rows here, resulting in these values here. And now let's look at S here. For S, we have 3 inputs here, which is P, Q, and R. So we have P, and then Q, and then R. They are all going to an AND gate here, meaning that all inputs must be 1 in order for the output to be 1 here. So for the first row here is going to be 1, 1, 0. So S is going to be 0 here. And then we repeat the same process for all the other rows here, resulting in this value here. If you look at this, only this row here, whereby we have 1, 1, 1, results in output of 1 here. And finally for Z here, this is an OR gate here. So we have 3 inputs again, which is P, R, and S. So we have like S here, and then P here, and then R here. So in order for the output to be 1, since this is an OR gate here, either input is 1, then the output is 1. So we have 1, 0, 0 is going to be 1 here. And repeat the same process for all the other rows, resulting in this value here. Therefore, if you look at this, when P, R, and S is all 0 here, this is 0 here. And then for the last row as well, 0, 0, 0, the output is 1. And all the remaining rows, they are all 1 here. Complete the Karnaugh map, K-map for the Boolean expression. This is quite a doable question. You just have to fill 1 into the table based on the expression here. So the first one here is going to be 0, 0, 1. Therefore, we will write 0, 0, 1. This is going to be 1 here. And next is going to be 0, 1, 1. So 0, 1, 1, this is 1 here. And next will be 1, 0, 1. So 1, 0, 1. So this is 1 here. And finally 1, 1, 0. So 1, 1, 0. So this is going to be 1 here. And then we will fill in the remaining boxes with zeros here. And next, draw loops around appropriate groups in the K-map to produce an optimal sum of products. So the group must be power of 2s or just single cell. So first of all, we have these 2 1s here. And then another group here, which is these 2 1s here. For this 1 here, we don't have to circle since it's just an individual 1 here. For part 3, write the Boolean expression from your answer to part B2 as a simplified sum of products. Do not carry out any further simplification. So for this question here, first of all, let's look at this horizontal circle here. So the common multiplier is going to be A equal to 0 and then C is going to be 1 here. Therefore, we can just write not A dot C. And then for this vertical circle here, B is equal to 0 and then C is going to be 1 as a common multiplier here. So plus not B dot C. And finally, for this individual cell here, we can just write A equal to 1, B equal to 1, and then C is equal to 0. So it's going to be plus A dot B dot not C here. As you go through this past paper with me, you may notice that you still need to improve some topics to score well in your paper 3 exam. If you want the fastest and most direct way to get top grade for your dream university, check out my fast track program at www.hagwin.school. Inside the program, I teach you exactly what you need to know from chapter 13 to chapter 20. I also cover chapter 19 and chapter 20 just for paper 3. There's also a paper 4 program focused only on coding, so you learn the right skills for each paper without getting confused. If you don't want to waste time on topics that won't be tested or spend money on help or resources that doesn't work, check out my fast track program today. And now let's go to question 7. Asymmetric encryption is a type of cryptography. Identify one other type of cryptography. So a symmetric encryption is using a pair of keys, a public key and a private key. For encryption that uses a single key, we can write symmetric encryption. An organization holds two asymmetric encryption keys, which they intend to use to receive secure transmissions. Explain how the organization makes use of the two keys to receive a secure transmission. First of all, we can write organization holds two keys, a private and a public key. Then the sender obtains the organization's public key. And then we can write the sender uses the organization's public key to turn the message into ciphertext. And finally, the organization uses its private key to decrypt the message. This is the typical workflow for asymmetric encryption. If you know the process by heart, this is a 3 marks question. State the purpose of the optimization stage in the compilation of a program. We can write to improve the code by making it use minimum resources such as CPU, memory or storage or time. And next, convert this reverse Polish notation RPN back to its original in fixed form. For this type of question, normally I will split them into group first. For example, we have AB minus, which means A minus B, then C plus, which means plus C, and then CA minus, which is C minus A, and finally D slash, which is divided by D. And then finally, we can just come up with a final equation, which is A minus B plus C bracket, which is this one here. And then multiply based on this operator here, and then C minus A with bracket here, and finally divided by D here. For this question, if you can split them into group first, this is actually quite straightforward. For C, the RPN expression is to be evaluated where A equal to 3, B equal to 16, C equal to 9, and D equal to 6. Show the changing contents of the stack as the RPN expression is evaluated. For this question, this is straightforward. We just have to put these numbers here following the operation from this column all the way to the last column here. And now let's do this together. First of all, C is equal to 9. So the first column here is going to be 9. And then A equal to 3, so 9 and 3 here. And then division here, so 9 divided by 3 is equal to 3 here. And then we have B here. So what is B? B is 16 here. So 3 and 16. And then we have D, which is equal to 6 here. So 3, 16, and 6. And then minus here. So 16 minus 6 is equal to 10 here. And then we have multiplication. So 3 times 10 is equal to 30 here. And then we have B, which is 16 here. So 30 and 16 here. And finally, we have plus here, which is 30 plus 16 is equal to 46. So for this question, just follow the operation from left to right, and you will be able to come up with the correct solution. Deep learning is a form of machine learning. State one example where deep learning is used. So the typical example would be self-driving cars. And then identify how deep learning can be made more effective. We can use more hidden layers. Next, describe the backpropagation of errors method in machine learning. This is a 4 marks question, so we have to write at least 4 points or statement for this question. We can start with initial outputs are compared to expected outputs. This allows us to calculate how far the model's prediction is from the correct answer. And then calculus is used to find the error gradient in the obtained outputs. And then the errors are propagated backward through the network. It means that we look from the outer layer back to the inner layers to find out which connections caused the mistake. And finally, weightings of each neural connections are adjusted to reduce these errors. This process will be repeated many times so the model becomes more accurate over time. An exception is an error that may cause a program to halt unexpectedly. Describe how program termination due to an exception can be avoided. We can use an exception handling routine to respond to unexpected events when the program is running. And to get a second point, we can use the sample pseudocode here. We can write use of try except code to catch the error. And then identify two possible causes of exception. The first one will be coding errors. And the next one we can just write hardware failure. The table shows assembly language instructions for a processor that has one register, the accumulator ACC. The current contents of memory are this value here. Write assembly language code using only the given instruction set to store the contents of location 300 as label variable A. Store the contents of location 420 as label variable B. Add the value stored in the address contained in variable B to the value contained in variable A. Store the result in variable answer. Show the initialization and values of the variables A, B, and answer in the table provided. Let's start from the first instruction here. We have to store the content of location 300 into variable A, meaning that I have to load this 86 into our ACC here, and then I have to store this into variable A. So I can just write LDD 300, meaning that I will load this content into my ACC here. Now ACC is going to have value of 86 here. And then I have to store in this variable A, so STO A here. And then for the bottom table here, we can just write A colon and then 86 here. And then for the second instruction here, we will repeat this process here. So LDD 420 here. And then ACC will contain the value of 150, which is this value here. And then I have to store this into variable B here. So right now, STO B here. And for the bottom table here, I can just write B colon 150 here. And then for the third instruction, it's going to be a bit more confusing here. What happened here is that I have to look at this value 150 here, and then I will take the content in address 150 here, meaning that I have to load this 26 into ACC here, meaning that I have to use this LDI instruction here, which is indirect addressing, something that we learned back in chapter 4 of the syllabus. So I can just write LDIB here, meaning that right now the code will first look at this B here and look at this address 150 here. So what is inside address 150? It's going to be 26 here. So ACC will have the value of 26. And then we have to sum this ACC value with the value stored in variable A here. So I can just write add A here, meaning that I will add the content in A with this 26 here, results in ACC equal to 112 value here, since 86 plus 26 is equal to 112 here. And finally, I have to store the result in variable answer. So STO answer. And then not to forget to update this table here, which is answer colon 112 here. So this question, it might look a bit complicated at first, but if you follow my step here whereby I show all these ACC value as we trace through this assembly language instruction, it's actually quite doable. A stack has been implemented using pseudocode to store a maximum of 100 string items using the global variables in the following table. The value of top is incremented each time a data item is added to the stack and decremented each time a data item is removed. If the stack is full, an appropriate error message is output. Complete the pseudocode for the procedure to add a data item onto the stack. So this is a typical pseudocode for stack operation. First of all, procedure push. So what do we push into this stack here? So it will be 100 string items here. So this is the string data type. So we can just write new data colon string here. And then if top less than max minus 1, then meaning that let's say the stack is not full yet, then what we could do is that we have to update this pointer here. So if you look at this visualization here, let's say this top, it has some data here. Right now, we'll move this top pointer to the top here, meaning that top is equal to top plus 1 here. So right now, this top will be updated to this location here. And then stack array bracket top is equal to new data here, we will be putting new data based on this updated top pointer here. And let's say the array is full now, we can just output stack is full here. So for this kind of stack operation, I always ask my student to visualize this stack of plate here. And then we can just visualize the process and write down the corresponding pseudocode. Write pseudocode to input a new data item and add it to the stack using push. For inputting data, we can just write input my data. And then we'll call the stack procedure by writing call push bracket my data here. Explain the reasons why a stack is used when a recursive algorithm is executed. First of all, stacks store data in first in last out philo order, meaning that old data will be at the bottom and new data will be at the top, like the stack of plates here. Next, each time a recursive algorithm calls itself, data is pushed onto the stack. So if you look at the Fibonacci example here, let's say we want to find Fibonacci 3, we will first put 3, and then 2, and then 1, and then 0. And then when the recursive algorithm reaches its base case, data is popped from the stack in the reverse order to which it was pushed onto it. So if you look at the example on the right here, this is exactly what happened here. We reached the base case of 1 and 0. And then now we'll start popping the 2 and then finally 3. Therefore, Fibonacci 3 is equal to the value of 2 here. I hope you learned something new from this partial walkthrough. As mentioned earlier, if you want to improve your revision for paper 3 or paper 4 and get the best possible grade for your exam, check out my fast track program at www.hagrid.school. I have helped students from over 30 countries to reach their target grade and get into their dream universities. If you are serious about your result, this program is for you. Lastly, I wish you all the best for your revision. Thank you, and I'll see you again then. Bye bye.